Alright, so one last small topic, which is about outliers and influential point. So outliers are points, they're not part of the cluster of our data, which means these points depart from majority of the data. And there's like no quantitative way to determine what outliers are, so usually all we do is we do visual inspection. The outliers should be the points that are visibly far from other points. Yeah. And influential points are outliers when removed change the least square line. Substantially. Okay, so for the original data, we have a least square line, and then but we have a few outliers. We want to see if these outliers influence the least square line. So we calculate the least square line before removing the outlier and after removing the outlier, and then see if the two lines differ substantially. And again, the word substantial is really vague. So this is also again by visual inspection. So there's like a lot of vague definitions. There's no consensus on how different does it mean substantial. So it's a little vague here. Anyway, so let's look at an example here. Okay, so this is the original data. So you can see there's a cluster of points, and you can clearly see there are 2 points that are kind of far from the cluster. So here's an outlier 1, and here's another outlier. Let's call it outlier 2. Okay, so we want to see if these outliers are influential points. So let's remove them one at a time and then calculate the least square lines before and after removing them. So the graph in the middle is with outlier 1 removed, and 2 is still here. And the graph on the right is the one with outlier 2 removed with outlier 2 removed. Outlier 1 is still here. So we look at the equation of the least square line. You see, when we remove outlier 1, the coefficients change a lot. So this is can be classified as a substantial change. From 0.88 to 0.71 is a lot of change, and from 2.90 to 3.7 is a huge change. So this is a substantial change, which tells you that outlier 1 is an influential point. And if you look at the third graph, now if you want to compare these coefficients, notice that 0.86 and 0.88 are not that far apart, and 2.71 and 2.9 are not that far, only off by 0.1. So this is not a substantial change. So we say outlier 2 is not an influential point. So this is how we classify influential points. Sometimes rather than saying whether a point is influential or not, we can say in relative terms. So instead of saying outlier 1 is an influential point and outlier 2 is not an influential point, we can say outlier 1 is more influential than outlier 2. Because we know for sure outlier 1 changes the least square line more than outlier 2. So sometimes it's better to speak in relative terms. So that's it for section 7.4. Right.